went to a few websites. I just did a Google how much water is in the atmosphere, you know. And this is the USGS website, usgs.gov, Science for a Changing World. The USGS Water Science School talks about there is always water in the atmosphere. Clouds are, of course, the most visible manifestation of atmospheric water, but even clean air contains water. Water in particles that are too small to be seen. One estimate of the volume of water in the atmosphere at any one time is about 3,100 cubic miles, or 12,900 cubic kilometers. And it goes on to say that if all the water that's in the atmosphere were to rain down at once, it would cover the globe to a depth of about 1 inch. And this is confirmed on a number of websites, but I'll just show you one more just for the sake of argument here. This is the Why Files, the science behind the news. They have an article, How Much Water is in the Atmosphere. It says, at any moment, the atmosphere contains an astounding 37.5 million billion gallons of water in the invisible vapor phase. This is enough water to cover the entire Earth, land and ocean, with 1 inch of rain. And of course goes on to talk about that as well. So, yeah, there's a lot of water in the atmosphere. I think we all kind of just know that, but I don't think we've ever really thought about what that means. If the atmosphere, especially over water, is made up of zillions and zillions of tiny convex drops of water, then collectively perhaps they all combine to make one big convex lens, in which case it would act like a magnifying glass.
Science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
So the atmosphere really is acting like a lens, according to the experts. Now, you guys don't need to go out and spend tens of thousands of dollars to get that pretty piece of paper to hang up on the I Love Me wall and put letters after your name so that you can call yourself an expert. You can be an expert with what you see here on the screen. Yep, believe it or not. Go to Walmart, and your advanced degree in atmospheric lensing technology will cost you just a couple dollars. You can get a 2x power lens for about $1.85, I think, at Walmart. Get yourself some Scotch tape. Then if you look in the description below, you'll see I put a PNG file of a city. You can print that up, cut it out so it looks something like this, what you see on the screen here. Then find a table and a chair. And okay, you're going to bend the paper so it looks something like this. Tape the lens to the table, get a chair that's about the same height as the edge of the table. Put your iPhone on the end of the chair, and the chair will act as a dolly, so you can just kind of pull the chair back. And looky here. Look what happens with atmospheric lensing. Wow, isn't that amazing? And you didn't have to go to college either. Now, you can get in a boat and drive to Chicago, and wow, look at that. Now, let's compare. See? Look at this. This is how much of the city was lost simply due to atmospheric lensing. Now remember, the experts, the guys that spent tens of thousands of dollars to get advanced degrees in this stuff so that people would recognize that they're smart, they told you the science really is that of a lens. So, to alleviate the problem of distorting the edges because the magnifying glass ring is too small, I went on Amazon and I got these plastic magnifying sheets and came up with another way of doing the same thing using the sheet right here. Set the city up, a little cutout of the city, and now I've got the big magnifying glass sheet. Bring the camera right up to the lens. See, that's the normal view of the city. Now let's back up again.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here,
The atmosphere really is acting like a lens.
yes.
Atmosphere really is acting like a lens, and this is how much of the city is missing due to the lensing effect, the magnification of the atmosphere. You're missing, a good portion of the city just by pulling my iPhone back on a 3-foot long desk. Got my magnifying sheet frame, and I created a little stand to paste the sun on it and keep it the same height over the flat surface of a table. So the sun is always going to be parallel with the surface. And check this out. All right, here's the first test of a sun moving over a flat surface, and with no atmospheric magnification, it does what we might expect it would. It gets smaller as it goes away from us. All right, now let's see what happens when we add in our atmospheric magnification. Again, water and refraction. Water causes magnification and refraction, right? So let's bring the sun back. Oh, check this out. Refraction bends the light downward. It made the sun set on a parallel surface. As it was moving parallel, the same height, the whole way over a flat surface, the refraction caused the sun to set. Not only that, well, let's bring in the beginning of that little test, and we see that it maintained pretty much the same size too. Pretty close. And of course that's because as it's moving away, the magnification is still taking place, and so even though the sun's further away than it was in the beginning of the test, the magnification basically preserved the same size, and the refraction made it set.
Flat Earth model had a big problem, a very big one, and I think we solved that problem.
How many of you think that the flat Earth model doesn't make sense because the sun would never rise and set, but instead be visible 24 hours a day? Welcome to the Steve and Dr. Zach Show.
Now, if you ask any scientist about his opinion about the flat Earth, he will ask you this: how do the sunrise and sunset work on the flat Earth model? And the flat earther will answer, perspective. Well, that is not enough. I mean, perspective is just a little part of the answer, but it's not enough. So the scientist here debunks the entire model with one question. That was my only problem ever since I started to study this flat Earth model. I knew it was not the only reason why the sun disappears the more it moves away from us, you know. And 15 months ago, I started to work on this with Chandra Seke, aka The Man, and then we teamed up with Steve Torrance, and together we solved this puzzle.
The answer was always in front of us. We just didn't see it like fish don't see the water. Now we can model it and understand the flat Earth model more than ever before.
Now let me summarize the story for you. At the beginning, we thought about something that we could add to perspectives to understand how the sun works, because we were sure that perspective was not the only reason why the sun disappears behind the horizon line, but we were not sure if our theory would work, and we had no idea how to test it. Steve already had a flat Earth model designed in his software, but there was something missing from it, and this something was the atmosphere. And we had no idea how to add this atmosphere to his model, if you know what I mean. If you take a look at any animation of the flat Earth, the atmosphere is always missing. It's like drawing the flat Earth in a vacuum of space. And this is why the sun never sits on the flat Earth, because there is no refraction. Now my question is, have you ever seen an animation of the globe Earth model with the effect of the atmosphere? I'm not talking about just drawing the clouds or the air. It's not just drawing them. It's how to make them work as they do in real life. You know what I mean? They know how the refraction works and they know how the atmosphere works, but they never add it to their animation, you know. And if they do, the sun would never set as they claim it does. And we can prove that too. The atmosphere is something that we can't ignore. It's like looking at the sun with your glasses on. The atmosphere is like a lens with no cover. We are like fish in the sea, you know. So the atmosphere can change the whole view of the sun. Now, in order to prove this, we had to add the atmosphere to Steve's model, but the question was how? It was not an easy thing to do, and by coincidence, Steve found out that his program is capable to model the atmosphere exactly how it is. So he took the data from the internet and built all the layers of the atmosphere, and suddenly the magic happened and everything started to make perfect sense. And when I say everything, I mean everything. The sun started to rise and set, and it started to match reality more than the globe model does.
With 3D software, you can model the atmosphere very accurately using refraction settings. We're not talking about drawing it and making it visible. We're talking about drawing the layers with their real effects on sunlight. Once I discovered it, I told my team, guys, we've got a solution. We can test the atmosphere's effect on the light.
After we had everything fixed, we started to compare it with real life. We actually took some real sunset videos and compared them with both the flat Earth model and the globe Earth model. And guess what? If you play the 3 videos at the same time, you would not know where the flat Earth model is, because it really looks like real live videos.
Many scientists think that the flat Earth model can't work because it can't represent sunrise and sunset. What are they going to say after studying this proof? Is it going to make sense to some of them now? They can't ignore the atmosphere, and all we did to make the flat Earth model work was add the atmosphere exactly how science represents it. We didn't make it up. This is how the sunrise and sunset started to work on the flat Earth once the atmosphere was added. In the description you will find a link to the original video. Compare it with this one and make your own conclusions.
We were planning to do an experiment to back up our theory, and Chandra Seke, or the man, was supposed to do it because he had what we needed, but because of the problems of life we had to postpone everything. But we will do many videos about this subject because it's the key to solve everything.
Thanks for watching.